Good morning. We're going to talk today about Section 8, Solving Systems with Cramer's Rule. And we're going to split this video into two parts because this section contains a lot of examples, and I think it'll just help keep file sizes down and stuff like that to split it up. So we're going to begin part one with our discussion of determinants. Okay, we need to define what a determinant is and how to find those determinants. So a determinant is a number that is associated with a square matrix. Okay, every square matrix has a determinant. And the notation for determinant is typically those straight vertical bars that's in the first, the second matrix, but the first one that says represented by. Or less often, sometimes you'll see it as DET and then parentheses with a matrix inside of it. Either one means determinant. Okay, and you have to be kind of careful because there's not a lot of difference between that first matrix that you see there with the square brackets and the second one that just has the vertical bars. So pay close attention. The vertical bars mean determinant. To evaluate a 2x2 determinant, it's a fairly simple pattern that we follow. And you may recognize this pattern. It showed up when we talked about inverses of 2x2 matrices. AD, if we start at the top left and go to the bottom right, that would be A times D, and then go to the top right, bottom left, BC. AD minus BC is the determinant for a 2x2 matrix. So for example number one, we can look at, switch to the document camera and take a look at this determinant.
For example number one, we're going to evaluate this 2x2 determinant. And all we have to do is follow the pattern in the notes there, AD minus BC. So 7 is in our A spot, 2 is in our D spot, 4 and -3 are in B and C. So 7 times 2 minus 4 times -3 gives us 14 minus -12. So that ends up being 26. And that's our solution for the determinant.
For 3x3 determinants, things start to get a little more interesting. By interesting, I mean complicated. There are a couple of ways that we can evaluate 3x3 determinants, and the first is a method called expansion by minors. In order to expand by minors, we pick a row or a column, either one, and what we do is we go through and eliminate a row and column at a time and evaluate the matrix that's left behind. So notice here in this example, the way it's written, I'm focusing on A, okay, element A. So I take element A and I multiply it by the determinant of the matrix that comes from all the things that are not in A's row or column. Okay, so notice I've crossed out the row that contains A, and I've crossed out the column that contains A, and that leaves me with EF, HI. Okay, now notice that I have moved that over to the B term now, so I'm eliminating the row that contains B and the column that contains B, so B is being multiplied by the matrix DFGI. Now we see that I've moved the vertical line over again, and I've crossed out the row and the column that contains C. So I multiply C by the matrix, the determinant of the matrix DEGH. So now hopefully you see where these three matrices are coming from. We're multiplying each of those matrices by the A, B, and C values from that first row. And then just keep in mind, you need to know this little matrix down in the bottom right that has pluses and minuses in it. That's the pattern that you have to follow based on what row or column you choose. Okay, if you choose the first row, like I did in this little example, then your first term will be a plus, your second will be a minus, and your third will be a plus. But say, for example, you wanted to use the second column or the second row. Well, then you would switch. Your first term would be a minus, second term a plus, third term a minus. So this little plus minus matrix is something that you need to keep in mind, it's not hard to remember. It's very easy to fill out because it just alternates every time. Plus, minus, plus, minus, plus, minus, plus, minus, etc. Okay? So that's expansion by minors. Okay, we're going to work this example on the document camera for expansion by minors. And we're going to use one of the rows or columns that contains a 0, because anytime you have a 0 in there, that saves you some work. So we'll switch to the document camera now, and we'll work this example.
In example number 2, we're going to evaluate this determinant using expansion by minors. And one of the things that's important to think about with with expansion by minors is that we can choose any row and any column that we want to expand by. So there's a couple ways you could go about choosing. You could look for numbers that are all relatively small, or you could look for a row maybe or a column that has a 0 in it to save yourself a little bit of time. So I think actually that's what I'm going to do. I'm going to pick a row that has a 0 in it. So I'm going to expand along the third row. Okay, so I'm going to have 6 times some determinant. I'm going to have 9 times some determinant, and I'm going to have 0 times some determinant that actually won't even matter because multiplying by 0 makes it go away. So remember, we need to figure out our signs for this, and in the notes you saw that matrix that had pluses and minuses in it. The third row was a plus minus plus, so that's going to be a positive 6 minus 9 plus that 0 term. And now to figure out what these smaller determinants are, I have handy a couple of little Lego pieces, so I'm just going to kind of cover up the 6. Okay, using the 6 as my sort of central point there. If I cover up the row and the column that the 6 are in, then I'm left with 7, negative 3, 5, negative 4. And then next I'm going to cover up the 9, kind of use the 9 as a hub, and what I'm left with there is 2, negative 3, negative 1, negative 4. And then again, it doesn't really matter because I'm multiplying it by 0. I'm not even going to bother evaluating this determinant, but just for practice, if I cover up the column and the row for 0, I'm left with 2, 7, negative 1, and 5. So these are the three matrices that I now have to evaluate. So this will be 6 times 7 times negative 4 minus 5 times negative 3 minus 9 times 2 times negative 4 minus negative 3 times negative 1 plus, and then 0. Okay, I'm not even going to worry about evaluating that last determinant because I don't need to. So here I have 6, negative 28 minus negative 15, make that a bracket, minus 9 times, this is negative 8, minus 3. So 6 times, what is that going to be? It's negative 28 plus 15 is a negative 13. Minus 9 times negative 11. So let's see, 6 times 12 would be 72, and another one would be 78. So this is negative 78 plus 99. So it looks like that'll be 21 as our final answer.
The second method for evaluating 3 by 3 determinants is called diagonals. And this actually is very much like it is for 2 by 2s, only there are more diagonal rows that we have to deal with. So the way it works is we begin by multiplying the first diagonal that begins at A and goes down through E and I. So we multiply those 3 terms together, A, E, I. Then we move to the second diagonal. Here we see the second diagonal begins at B and ends at G, so we multiply B, F, G. And then I think you're probably picking up on the pattern by now. We move that line one more time, we get C, D, H. And then for the second set of diagonals, we actually start bottom left and go to top right. So we can see we have C, E, G. Move that line over, we'd have A, F, H. move it over again, we have BDI. So for those upward diagonals that start at the bottom left and go to the top right, we subtract each of those. So we multiply the products of the terms and then subtract those results. So the primary diagonals that start at the top left and go down, those we add. The upward diagonals that start at the bottom left and go to the top right, we subtract those diagonals. Here is an example that we can work on the document camera for evaluating 3x3 determinants with diagonals.
All right, so example number 3 is another determinant, but this time we're supposed to evaluate this using diagonals. So to do that, I'm going to start out by rewriting this matrix, and I'm going to include at the end here the first 2 rows again. Sorry, first 2 columns again. Like that. Okay, so now what I essentially have is like a 3x6 sort of. So the diagonals method works by starting with your kind of main diagonals. Okay, starting, I can't obviously leave that there because you can't see the numbers, but be the first diagonal, then be the second diagonal, and that'll be the third diagonal. That's why we need these extra 2 columns, so that we know what numbers to use, a little more visual, it's a little easier to see. So we'll have 3, 6, 3 to start with. All right, plus the next one will be 0, 2, 8, so that's just a 0. And then -1, 4, -2. All right, so that's the top left to bottom right diagonals. Now we switch to doing bottom left to top right diagonals, and we'll do all 3 of those. So the first one is 8, 6, -1. And we're subtracting each of these. We add the first 3 and then we subtract these 3. So next is -2, 2, 3. And then lastly we have 3, 4, 0, which is just going to be another 0. So that's how we set up our diagonals. Okay, that's really kind of the main important thing to pull from this, because after this it's just arithmetic. So 3 times 6 times 3, that would be 9 times 6, 54. The 0 is obviously 0. -1 and -2 make +2. 2 times 4 is 8. So we have 54 plus 8 minus 8 times 6 is 48. And negative makes a -48, so I'm going to say plus 48. And then -2 and 2 is -4. So this is -12. Minus -12 is plus 12. And then obviously minus 0. So let's see here. 48 and 12 is 60. And 54 and 8 is 62. So it looks like we have 122 for our determinant on this one.
Okay, that concludes part 1 of our 9.8 video lesson. So hopefully that gives you guys a good overview of what determinants look like, how you evaluate them, and we'll be able to move on to Cramer's rule in part 2.